morning, good afternoon, good evening, good whatever time it is, whenever you're watching or listening to the podcast. Hey, this is Malcolm Hawker. I'm the host of the CDO Matters podcast that you're listening to. Thank you for checking us out. I'm also the CDO of Prophecy. We make amazing MDM software. If you ever have MDM related problems, hit me up on LinkedIn, send me a DM. We'll have a chat about MDM, my favorite topic. All right, today we are going, speaking of favorite topics, the one we're going to talk about today is up there for me. So we're going to talk today with Andreas Blumauer. Andreas, hello, how are you?
Hello, Malcolm. I'm doing well. How are you?
I'm excellent. So today we're going to talk about knowledge. But we're not going to start our conversation talking about knowledge or knowledge management. This is a topic near and dear to my heart because I sincerely believe that we as data leaders need to pivot more towards knowledge management. But we're not going to start with that. We're going to start with a little bit of a history lesson. We're going to talk about the semantic web. And we're going to talk about some early efforts to bring structure to metadata in our world and the kind of the web writ large. Andreas is the founder and CEO of a company called the Semantic Web Company. He's now a senior vice president of growth at GraphWise. GraphWise is a combination recent merger of the Semantic Web Company and another company called OnToText. OnToText was, and maybe still is, or was a graph database company. If you want to learn more about graph, I actually talked to an extremely smart fellow Gartner alumnus named Summit Pal on episode 65 of this podcast. So if you want to go into some of the really technical details of what is graph, if you hear us talking about graph today and graph databases, graph triples, graph nodes, if you hear some things, you're like, what's that? Episode 65. Sumit is a super smart guy and goes into a lot of the details. The episode is called Demystifying Knowledge Graphs. So if there's things that we're talking about today don't make too much sense, hey, tune into episode 65. I also talked to somebody else from OnToText, Doug Kimball, the former chief marketing officer, in episode 26, where we're talking about graph from a business perspective and why should business people care about graphs? Why should this even be relevant? So we've got a lot of content related to graph on the CDO Matters podcast. If some of the things you're hearing today don't make that much sense, check out some of those earlier episodes. But Andreas, let's dive into it. Tell me, what is semantic web? What is the whole concept behind semantic web, and why, as a data person in 2025, why is that something I should probably know?
Yeah, semantic web, it has a really long story attached to. So it's like started out somewhere 1998, I think it was, when Tim Berners-Lee was publishing a little note on its W3C server called the Resource Description Framework, RDF. And the whole idea was always, okay, obviously the web became a very busy, crowded place with a lot of different, let's say, formats and interfaces and whatsoever. And the whole idea was, okay, let's build a second web, which is the semantic web, parallel to it, or also somehow embedded in the meantime, which allows to access machines in a really standardized way. So the data, which can be produced in different formats, like for human beings to be consumed by human beings, but at the same time, also for machines in a standardized format. And this format, you shouldn't just think of how is it serialized. It's really about how does what the metadata and the description of the metadata, how that should be standardized. So we are all very focused on the metadata, like in the first order. But then when you think of this massively, this scaled out system called the World Wide Web, you cannot trust that the authors, all this metadata, will have a consistent view on their metadata. Of course not. So and also in enterprises, you see that at quite large, smaller scale, every department starts to create maybe some kind of quite specific metadata, quite not interoperable, really. So the keyword is interoperability at scale. And that was the whole idea of the semantic web, that all the publishers of content across different domains should at least agree on the way they describe their metadata. And on top of that, the knowledge models, the ontologies and taxonomies describing the meaning of the metadata. So it was very important at that time, a bit later, 2015 or so, that the agreement on particular standards was slowing down to some degree. And at the same time, Web 2.0 already came up, which was actually siloing all the data. So it's, you cannot anymore access data except via APIs. In the majority of the cases, platforms have really captured the data and just control what they want to give away. So it's no longer a standard which is on the World Wide Web that powerful as it was supposed to be. I think it was at the very early stage of the web. Was a great idea if that would have converged, but it didn't, because what's missing really is also a way to let the user somehow control his or her own data. It was part of the semantic idea that you can set up a profile and say, okay, what I'm interested in, and then you can say to the one data provider, okay, I let you look into my profile from this perspective. I let the other one look into my profile from that perspective, and by that you would have still control over your data, but you haven't. Tim Berners-Lee at one point said, even I remember, he's quite disappointed how the World Wide Web has developed in what it has developed, and he should have, let's say, enforced the semantic web even earlier, more than the web of documents as we know it, right? But it's too late now, he said. And what in parallel was quite nice to see is that enterprises have started to adopt semantic web standards. So actually it shouldn't be called anymore semantic web. It could be semantic enterprise standards, really, because we see a lot of adoption of RDF technologies, COS, Sparkle, all that is now really all around in enterprises which want to implement an enterprise knowledge graph. So that's pretty much the same technology under the hood. An enterprise knowledge graph has adopted the semantic web standards.
Okay, let's recap. So is it correct to say that in the early days of the internet, the World Wide Web, that there was an effort to have some idea of open standards related to metadata exchange, and that's what the semantic web represented, was just kind of open standards for exchange of data across any resource on the internet. Okay, all right. But what instead involved was this closed environment where, I mean, you could look at it from the perspective of APIs potentially, where I publish an API, you have to adhere to my API standards, and it's very much, well, the web obviously isn't entirely peer-to-peer. But if I want to go get data from another company, for example, if I want to go exchange data with you, or if I need to go exchange data with some large data provider, it's largely a point-to-point interaction through API, where all the definitions are part of this kind of one-to-one interaction. Did I just kind of summarize things correctly? So what evolved instead of the semantic web? What is the closed environment that exists on the internet today that we just kind of don't see under the covers?
I mean, what's quite prominent is schema.org that was enforced by Google also to better understand the meaning of the content and their knowledge graph. So Wikidata was one of the driving pieces behind the Google knowledge graph. Actually, it was Freebase originally, then Wikidata came in. That's all based on the semantic web standards plus schema.org, and all this additional information was helping Google to build a more competitive search index. That's still not well understood, but that was one of the main reasons others couldn't do it at the same level of accuracy. So obviously, early days already, the fusion of knowledge graphs and machine learning, which Google brought up to the level where they are now. And interestingly, now Google also just recently has announced that their internal, the enterprise, like the big data query engine and so on, will be more and more complemented now by knowledge graphs. So the same pattern or design pattern now start to get embraced by the enterprise data people inside Google. So that they obviously have learned a lot on the web how to do that, and try to bring that now into the enterprise data environment. Like many others, SAP has just announced, the SAP knowledge graph is orchestrating the agentic AI framework. So knowledge graph now are really prime time. And since you mentioned Sumit, my colleague Sumit, just before, Gartner now has also put knowledge graph at finally next to the plateau of productivity. So it's really no longer a second class citizen in the AI strategy. Typically, it's at the forefront, and it just helps enterprises to make their data AI ready. And that's the key element.
Okay, I was using APIs as kind of a metaphor for data exchange, trying to understand, okay, how is data being exchanged at scale today through the internet? But what you described was the use of knowledge graphs as a way, with I assume RDF being the primary. Are there others besides RDF in the knowledge graph world?
No, absolutely. There are
Turtle,
there are two well-known kind of approaches. So RDF is an open standard, as you said, and builds the basis for the knowledge graph community. And then there's a property graph community, and they use LPG as the, let's say, underpinning methodology. It both have their absolutely the advantages. That's clear. It's not the one superseding the other, but we can come to that later. So it depends on the use case, and it comes to the use case and the data which is used in the particular use case, if you choose the one or the other. And it's also a bit a strategic question enterprises start to ask themselves. So and depending on that, you either go for RDF or for property graphs.
So, I mean, I'm trying to wrap my head around the idea of there being this common standard for metadata exchange between companies. I mean, in my world today, this is obviously relevant, right? If I'm trying to share data, I'm a healthcare provider, I'm trying to share data from one healthcare company to another healthcare company. Or if I'm part of a manufacturing kind of supply chain, I've got information related to my products or, that are part or supplies and materials that are being passed from one company to another. And I'm trying to wrap my head around historically how we've been doing that, right? Versus the world that you're kind of describing. And maybe, am I focusing too much on the world of structured data versus unstructured data? Help me understand the difference between a simple file exchange, for example, where I send you a file, or maybe we exchange some data over an API. What is the difference between what I've described and kind of historically how companies would potentially be sharing data between each other, and a world enabled by these knowledge graphs that are powered by some of these standards like RDF?
I mean, what's important to state is the kind of the way metadata is described in semantic web standards and knowledge graphs is fundamentally different to other technologies. So it transports the meaning together with the data. So it's a self-described. You would never find a documentation about what does this data mean in our world. It's just self-describing, and you use ontologies also to make sure that the data is valid. So you can run tests and see is your data consistent, is it complete, and so on and so forth. And all that is done in a way that it's self-describing for the machine itself, understandable. And so if you want to build interfaces on top for the people and for the data engineers. And that's the beauty of this standard, that you can a domain in a domain specific way, you can express what's needed in your domain, that your data makes sense. And those things are called taxonomies ontologies, and those are used on top of the metadata. And you can do it with any kind of data. It can be a document, it can be a semi-structured document, a completely unstructured document, it can be SQL data, can be anything you can imagine. You can just use that as the baseline, put your metadata, which then again is described by using ontologies, taxonomies in a standardized way. And this use as a package and bring it over to your peer. And this way to transport data adds something on top. It's really more about knowledge exchange than data exchange only. So it brings data to the next level. And this is so important in days of AI, when AI would love to get to the point where the real, like in RAG architectures, you really want to know, okay, where resides actually the most relevant data unit. You need the metadata and the description of the knowledge model on top of the metadata even more than ever before. So now it really starts to pay off to build this knowledge graph like an umbrella on top of all the data silos you have in your company. And this exchange of data across silos and enterprises is now the predominant use case. Of course, also to integrate external data, like when you are probably subscribed to a data provider and you want to link it back to your enterprise data in a meaningful way. All that can be better automated when you have this knowledge graph infrastructure in place.
So wonderful answer. Thank you. Still my first cup of coffee waking up here this morning. And that was really, really helpful, because I'm thinking here, I was like, hey, well, I send files. I can send a record, I can send a file, but there's something inherently different between there being some checksums on a file exchange, right? And exchanging context and meaning, right? Where what you just described, which I love, which is something that is very self-describing, right? I can send somebody a file of customer records and I know it's customer records, but that's pretty much it, right? I may know that maybe there's a bit on, the active flag for customers, so that I know maybe that they're active. There's things that I can do in a relational database to kind of add a little bit of context, but what you could be describing through a knowledge graph is so much more rich because of the kind of the natures of how knowledge graphs work vis-a-vis these triples, correct? And is that the self-describing that you're talking about, which is these triples that are kind of inherent to the graph that tell me things about the data that I would never know from a relational data store?
Yeah, on a very atomic level, it's triples. It's for me, I think it's very abstract. I would rather rephrase it to some degree and say, okay, you have a record, data record, and you put some metadata on top. Let's say I have it in front of me. Let's say coffee, water, and mouse.
Yeah.
Good. What does it mean? Yeah. What is it? What does it mean to the other agent, to the other application? What's water? If the data comes from let's say an industry plant, and it means, okay, maybe water consumption. If it's then sent over to a government agency, they probably look at water in a different way. So we need, first of all, have a bit of an idea. So what is meant by that kind of data? And this can be described in a knowledge model. And this knowledge model can make use of standards like SCOS and OWL and all that. And yes, essentially there are triples inside, but this is too small to understand what the semantic web really does. It's about the knowledge models, the domain models, which make the difference. Also to the property graph community, they cannot handle that very well. And I think that's the point we should look at. So we need domain aware data, a data set which understands, so to speak, a little bit itself. Yeah. So what I am all about as a data set, I'm describing the water consumption of an industry plant. So then just expose that. Make it clear to the agents out there via maybe MCP protocols even. And this can be automated with knowledge graphs now. And there are a lot of vocabularies out there which make this content production in a way more interoperable. For instance, medical subject headings, is used widely across the medical and life science industry. A lot of companies, use MASH, or other examples would be Eurovoc. That's widely used in the European Union. It's the European vocabulary to annotate, for instance, protocols on political fora, right? So you really know what they are talking about. So it's not so trivial as you would believe to understand if the data is relevant for me or not. They cannot be decided by artificial intelligence. That's not possible, because those guys don't have the bigger view. Not the context is missing in most cases. So in other words, what we are doing really is providing a context engine into this architecture, which allows to shrink the space relatively quickly into the most relevant content nuggets, right? It's really small chunks of content which are most relevant. And vector embeddings, come on, this is not a nice technology to do that. So it's random. That's really random. So vector is not good to relevancy ranking on the level it should be.
So your concern with vectors are, what is it? Is they're too simplistic? I mean, if you're just kind of looking at chunking out blocks of text and then drawing some conclusion based off the block of text, is that just kind of, you're saying that vectors are limited because they're missing the broader picture? Is that kind of the story you're trying to tell?
Yeah, I mean, just look at a simple workflow. Somebody asks a question in a chatbot, and that's the whole context you get, right? And then you use a large vector space model to find relevant information. That doesn't work. So you really need to understand, so where does this person come from? What's the context this person currently sits in? And here we're talking about domains, knowledge domains typically. So when working in a particular field of a particular company, or along the lines of a defined process to stay compliant with a certain regulation whatsoever, there's a lot of context typically available to understand the user intent better. And this needs to be very accurate. If you're working, let's say, in a financial sector, and someone asks a specific question, and we need to know exactly, so what are the regulations which are important in such a case, and that shouldn't be randomly chunked up by a vector model. I mean, if our brains start to work like a vector RAG, then we are done finally. Now this is then really the complete idiocracy.
So I get it. So I can see now, from the perspective that you just gave, which is this kind of very self-describing, contextually rich source of data, this is something I could easily see why LLMs would be, why these are, knowledge graphs are so powerful when it comes to LLMs, because they absolutely need that context in order to limit hallucinations, to improve the accuracy results. I mean, I could go on and on. I think our mutual friend Juan Cicada has done some interesting research here about using graphs to kind of ground and improve the behavior of LLMs. So I can certainly understand that. What about, can knowledge graphs play a role from the perspective of governance? Could I build a governance graph that helped describe potentially rules that I would expect to see from a governance or data quality perspective? Is there, and I'm really kind of wondering out loud here without a full cup of coffee in me yet, but I can certainly see how you could use a knowledge graph to make data far more AI ready. That I get. I'm trying to understand where a kind of a more of a legacy governance model would fit into this world, particularly from a data validation, kind of data accuracy perspective. Have you thought at all about this?
Yeah, sure. So another important feature of knowledge graphs is that they're very well prepared to do data integration across multimodal data sources. And so RDF is kind of a super language, if you want. So you can map quite everything to RDF. And by that, you can do, for instance, with the help of Shackle, which is part of the standards stack, set up a set of constraints to make sure the data follows your set of rules across the silos. So not just for a particular silo anymore. So probably by that you detect finally data inconsistencies you otherwise would never ever have surfaced, right? So step one, you transform, and that by the way can be also virtualized, but typically you materialize it, transform data from different silos into and map it by that into the knowledge graph, where you then execute your Shackle rules, and then you find out missing pieces or inconsistencies, etc. And that allows you really to bring data quality to the next level, right? And by the way, it's not just the LLM then necessarily producing the answer. You can also use GraphRag the other way around if you want, so that you make sure that in most critical queries the users have, it's definitely fact-based. So you go back to the knowledge base, to the knowledge graph, and force the system to give an answer out of the knowledge graph, which obviously is mirroring the approved data. And the LLM you can use to translate the natural language query into a Sparkle query, right? Sparkle is the query language in the semantic web stack, which executes on RDF graphs, sophisticated queries you could never ever execute with SQL databases, because too many joins at the same time wouldn't work in the SQL world. So it's a very powerful technology stack by that. And short answer to your question, yes, data governance with this technology in place probably comes to the next level.
Well, I could see how that would be. I could see how what you just described would be very powerful to identify outliers and exceptions, right? Or to find relationships or find conditions in the data that you wouldn't expect to be there from a quality perspective. This starts, I think, to me, starts to get into things like human in the loop and data stewardship, and how you do that in real time is a little perplexing to me. But we can put that issue aside. I'm trying to figure out in my head, while I was listening to you talk, of like, let's go forward a year or 2 years, and how do we bring everything that you just described closer to the world of traditional data management, right? And in my world of traditional data management, there's MDM, right? Master data management, which is where we have kind of managed definitions of things, and we manage quality standards of things, the things being shared data, customer, product, asset. We've got, traditional data integration, right? Which we've got traditional data quality. And my head is really kind of spinning, because I'm trying to figure out, how do we bring these things together, or do we necessarily even need to? I think we probably do, because the world of rows and columns isn't going away. Right? We're going to continue to have traditional analytics. We're going to have dashboards. We're going to have the things we've always been doing. But the world that you're describing is a very different world. And I'm trying to, in my head, figure out, how do we bring these things together? Am I being crazy on a Friday, or are these things that you guys are thinking about?
Yeah, I think it really starts from the top of the organization. If companies no longer want to drive the business just based on analytics, but also maybe more going in the direction of knowledge discovery, leveraging the existing data across silos. One keyword is collaboration. Also, self-service reporting is another one that more people will make use of data, democratizing the usage of data in general. I think there's no other way than moving forward with a knowledge graph, because that's the interface needed between natural language and the data. And there are very specific data models in relational data which have nothing to do sometimes with the actual business logic.
Right.
So
yes.
That's the key element here. The knowledge graph really is kind of a translator between those two worlds. And by that, you can imagine that far more people can make use of the data, ask questions about the data, and it's going to be translated into the, let's say, embedded or in the internal query language needed. And the knowledge graph using RDF just makes it even broader. So you can ask questions across different data silos. For instance, a customer of ours working in pharmaceutical space, they've integrated more than 20 data sources, quite heterogeneous, harmonizing all the metadata that was already in place. Nothing was changed there. So we added kind of a virtual semantic layer on top of that. And now the LLMs access the knowledge graph to give answers which can integrate or make use of all the different data sources in one go. So they have now the infrastructure to let different stakeholders ask their questions, where they can, make use of different data sources that probably wouldn't have otherwise find even. So that's not uncovered for many people. They don't know even in large enterprises that this data exists or this document exists. So it's really about this strategic decision. Do I want to bring the usage of my data and content to the next level and have simple interfaces for my employees, for my stakeholders, that they can ask questions they want and get the answers from the real sources, without hallucination? That's also important in that case.
So let's get a little more specific. I'm a big believer in kind of starting small and taking, when it comes to managing, governing data, start small, focus on specific use cases, and grow over time. I could easily see a world where people could be very attracted to, okay, these things called knowledge graphs, this is awesome, I need these. And I could see a world where it's like, hey, let's just go graph everything. Right? Like that could be a very, very time-consuming enterprise, I would imagine. What would a best practice look like for a company who is just starting in this? Is it use case bound? Is it am I going to help marketing to execute this one campaign, or what does it look like to start simple with getting to know knowledge graphs and getting to integrate them into your data analytics practice?
Yeah. Before I give an answer to that question, I really have to myth busting here, so to speak. So creating a knowledge graph is not more sophisticated or more time consuming than data and content management in general. It's just a different exercise, and a lot of stuff is automated in the meantime. So it's not like somebody sits down and develops the whole day ontologies and so on. This is no longer the case. So that was probably the early days of the semantic web. Everybody was kind of opening up a strange tool, creating strange ontologies, and only 2 people could read that. That's no longer the case. It more or less became a commodity. So we at GraphWise, we also spend a lot of attention on this build your graph part of this loop, so that the build your graph is more or less done automatically in the meantime, still the human in the loop to supervise the process. And then the graph obviously enhances the graph RAG application, and then you have some metrics in this loop, and then you can automate even the next iteration and determine which part of my knowledge graph are still kind of underrepresented, etc. So you really get to this more and more to this closed loop called recursively self-improving AI, with the graph in the middle, so to speak, or as an elementary part of this loop. But coming back to your question, of course, you cannot start and say, "Oh, I will do the fully fledged knowledge graph as a next step." No, you would start obviously with one, I would say, business critical application. That's a good start. It shouldn't be a nice to have problem you want to solve. Of course, to learn in the first POC, why not? But if you want to start with a first real world and productive use case, pick out one use case where you know when you can improve that, the business impact would be pretty high. And then there's a methodology in place. It's no longer like we randomly start somewhere. It's always the same procedure, more or less, to build the domain model, to ingest the data sets, transform, link them, test them, make them available to the GraphRag system, for instance, or it could be still a more analytics problem, or it could be also a search problem. So analytics, search, and Gen AI, those are the three typical use cases then on top of the knowledge graph. And then, of course, it's going to be tested by the end users who are typically domain experts. And then you iterate maybe a couple of times, and then you have a well-working system in place. And then if that works for this one particular problem, then of course you can apply the same methodology to more and more data sets and more departments, and then eventually everything grows together in this knowledge graph infrastructure. We call it the 5-star journey. Our customers start with 0 stars, typically maybe with 1 star, and several of our customers are in the meantime on level 5. So you get there, and depending on how strategically important it is for your management, maybe within a couple of months. If it's always a bit of a side effect only, let's see what the knowledge graph can do for us, then of course it takes longer. But now I think we see more and more enterprises loud and clearly saying, okay, we've understood finally, tried out everything, VectorRag didn't work. Let's go ahead with our knowledge, or let's go ahead with graph now, and it looks quite nice at the moment.
Well, something that I recommend strongly to my clients, and I recommended this when I was at Gartner, which is pick a use case, pick a problem that you need to try to solve. One I love to use all the time is like cross-sell or upsell, like just to understand where there could be additional sales opportunities that you don't already necessarily know about. And in my world of MDM, that's creating some idea of a 360-degree view, because you have a single ID that can go be used across the entire organization to link various IDs to the one master ID. I may have Joe Smith, Joseph Smith, JM Smith, JJ Smith, but they're all the same person. I've got one ID that links all those IDs together. And now I can go build a report that shows all the transactions related to those various IDs. But what you just described goes well beyond that, right? I wouldn't necessarily just be looking at the transactions associated to this person. I could be looking at other things. I could be looking at that person's household. I could be looking at other people that were related to him. So I think we may need to kind of rethink this idea of a 360-degree view is not necessarily about just kind of linking IDs together. It certainly is that, but what you described could go an awful lot further to help describe a company's relationship with a person or another person, or even with a given material or anything else for that matter. So I would love to figure out how to bring these two worlds together, because I still think we're very, very siloed, which is really ironic.
I agree.
Right? Given MDM exists to break silos, and you've been using the phrase breaking silos from the beginning of the conversation about how to more deeply weave these worlds together, because I'm not seeing that sufficiently today.
I mean, I can come up with probably a too naive or too simple example, but somehow it was a couple of years ago, a large bank came to us to show us their system, how they manage their assets. And there was a lot of metadata on top of this data records. And then we looked at the metadata, and said, okay, let's put metadata on top of metadata on this existing one, like new and additional classifications and also attributes and relations between these classifications to do even probably inferencing and reasoning about it later on. But what that allowed the bank to do instantly, and it wasn't a lot of work, we ran a POC with them, is just to ask, in addition to all the queries and all the reports they've done regularly, to ask additional ones. And it wasn't a lot of work in reality, because what we did essentially was what the humans, the experts had in their brain when they looked at the data, they did it anyway, always kind of, but not digitally. Yeah, they looked at it and said,
Right.
okay, if this and that is like the category attached to this asset, that means to me this and that. But why not putting that on top as a digital asset? Yeah, which essentially the knowledge graph is and the domain knowledge model is, and automate on that to some degree. And somehow those guys got stuck into in a world where this probably was not possible. Maybe in the 90s, I don't know. I was not, my career started in late 90s. So I don't know where this comes from, this rather rigid structure, but the knowledge graph is highly, dynamic. If you need additional metadata, just put it there. So it doesn't take long, to add those categories. So if the environment changes and you have a new regulation, just put the metadata there. Done. So and then you can start querying over all kind of assets you have, is it a bank or whoever, it doesn't matter. So it's not a technical issue. I in the meantime believe more and more it's more, oh, we've always done it like that mentality, so it works mentality, it's good enough mentality, and all that, and breaking up the silos sounds so dangerous to so many people. They want to stay in their controlled environment, in the box, and the box is beautiful, and you don't have to do anything else than what you've done in the past, and this graph is dangerous to many people out there, and that's the reason it's still a concept a lot of people try to push away. But now the environment has
well, that's a marketing problem. That's a marketing problem, right? If the capabilities are there and the value is there, what you just described was marketing problem. Those are the marketers. Those are the easiest problems to solve. I would answer if the value is there, the technology is there. Okay. Last question, because I do know we're running low on time. We've talked a lot about knowledge graphs and those insights for AI. What about AI for knowledge graphs? So I'm very intrigued by using AI to help me find relationships that I didn't even know exist, right? So today, human beings are still largely driving the models that are underlying these graphs. Is that correct? It's mostly humans that are kind of driving that process?
Yes, that's still the case, but as said before, we at GraphWise have already changed that and have built an LLM-driven model, which does exactly what you just described. So it adds own elements to the knowledge model on its own. Still, we let the subject matter expert supervise that process if needed, but it generates very good quality. So, I mean, I really have to say that the profession of an ontologist and taxonomist now tremendously changes these days. They like all the other jobs out there. Obviously, AI support and the right usage of AI is key. I'm not saying they're obsolete, not at all. They remain, but their role will change. So it's more becoming a knowledge steward, because they also have to find out what needs to be added to the knowledge graph to make the biggest business impact. By that, they need to understand the business and what's really needed more than ever before. They cannot create models like separated from the rest of the organization. It needs to get an integrated function, because the actual creation, or this nitty-gritty creation, new concept, new synonym or whatsoever, is no longer where you spend the majority of your time. This is done by the LLM. Of course, you still need to guide the LLM and bring in, the scoping, for instance, is very important. So what do we want to change in our business to be more successful? That's what the knowledge steward has to find out.
Well, the same is true in more kind of traditional, BI worlds. I know this isn't going to be a very popular statement, but I would argue that data modeling is very quickly becoming, shall we say, more of a legacy capability. Now, data modelers I know that are extremely good, they would argue, well, I can see things in the future and I can foresee things that humans, that the AI can't. That may be true. That doesn't sound very data driven to me, but that's fine. Separate, conversation over a stein of beer, maybe one day, about the relevancy of human modeling versus AI driven modeling. But one thing I know for sure, based on everything you just said, in my lifetime, I've had the greatest success providing insights when I was able to tell business people things they didn't know, right? Like the things that drove the aha, oh my God, I had no idea, right? I had no idea that we were selling this product to this business, or I had no idea we had this risk in our supply chain.
Right.
And everything you just described, if you can actually have AI find patterns in data that at scales that humans simply cannot, like that's the aha. I need some of that. So that's been my experience, and that seems like what you're kind of suggesting here. So that's very exciting.
Right. Yeah, I agree. It's an assistant which can come up with suggestions, which are always, you need to approve them. You need to find out if they're really true, especially in the domains we are working in. But it accelerates the way to get to the point where such engines can really become a trusted source, and that's where we are getting now. So these trusted sources are needed. I think still for many businesses we are not there yet. So they have this situation where they say AI works in, let's say, simple tasks already very well, but when it comes to very specific complicated tasks, we still cannot use it. That's where the knowledge graph comes in, because what's missing is the background knowledge, the domain knowledge. And to bring this domain knowledge even faster into this system, you can also use LLMs, but still you need the human in the loop. But when you close those loops into one, then it finally comes to the next level. You get to the next level. But yeah, there will be a bit of a, let's say, rochade regarding the roles in a company. I'm still very, very positive and optimistic. We cannot just now cancel a lot of junior jobs, because what's coming next if we don't have any juniors?
Exactly.
Yeah, in 10 years, 15 years, the organization is done. So we still have to educate our people that they understand the whole thing. And yeah, so it's going to be interesting how different organizations will fail with that and become too greedy. I think those who now become too greedy will in 10 years already have a big problem.
Yeah, you mentioned trusted source. That's the world that I live in. Our challenge historically around the trusted source, I think, has been this deterministic way of looking at it. Either it is or it isn't. And what I love about what I heard in our conversation today was that these graphs could provide the context needed in order to say, okay, for this context, this could certainly be trusted. In this context, maybe not, right? And it's all about the context and how the data is both produced and actually as consumed as well. So, Andreas, thank you so much for spending an hour with the community today. Really, really, really appreciate it. If you're still listening, please take a moment to, thumbs up on the video on YouTube, and maybe even subscribe to the channel. That would be awesome. We do this every 2 weeks. We're talking to some of the brightest minds in data and analytics across the globe. Andreas, thank you again.
Thank you, Malcolm. It was a pleasure.
Wonderful. All right.
Bye-bye.
Stay tuned, folks. Check out another episode of the CDO Matters podcast. Another 2 weeks. I hope to see you sometime very soon. Bye for now. Cheers.
Tschüss.